Now let's look at our property diagrams again. So here's a TS diagram. Let's say I have a process right here. And this is an internally reversible process. Okay? Now, for this process, whether it's part of some other relation or part of a cycle, the area underneath this process is equal to either the heat that has been released or the heat that has been added to make this process happen. Okay? So either the heat that's been released or the heat that has been added to make this process happen. Now, with that being said, typically we don't work in just one single process. And what we do here is we have cycles. Now this is for the Carnot cycle right here. That's why it's all nice and straight lines. And we don't use the Carnot cycle in real life. It's always just a way of figuring out our maximum efficiency or our maximum power output. And so we go from being just one process to being an entire cycle. What we find out is that the area inside of that process curve, or that cycle curve, is the work. And you're like, well, it was heat earlier, and yes, for a steady flow system, for a cycle, Q net is equal to work net. So it's the same difference. So what I see here, it's going from 1 to 2. That guy right there, that is the heat added. Okay? I'll just draw it with big. That was heat added, or I should say heat in. And then because it's getting colder later, sorry, not getting colder, because it's decreasing entropy later, this area right here is the heat going out. And for a cycle, our net work is equal to our net heat. So that's where we're getting this from. And the great thing from this is if you have a cycle and you're actually measuring all these values, but you don't get nice straight lines, your lines look something like this, you can still figure out I shouldn't have gone that far, my bad. If your cycle looks something like this, okay, let's just make it a horrible circle. You can still solve that. Like you can still figure out how much work it produces. All you gotta do is figure out where you start, figure where you end, divide it in half and figure out, okay, what's the area under the top? What's the area under the bottom? And subtract those two. You can do that with most methods. In most cases, if you're gonna, let's just make this crazy blob shape again. What you'll do is you'll take a bunch of rectangles and make them very, very small. That might be your time step. And by doing that, you can then get a very close approximation of the area. So we can use numerical methods to actually figure out what's really going on here. Okay, so just don't forget, we learned this way, way earlier on, and it hasn't gone away just because we've introduced entropy. We still have ways of looking at this. We still have ways of calculating it. And if you can figure out those areas, you can figure out the heat input or your net work output. It's all applicable to real world systems and real world problems. I think that's for this one. Yes. So thank you all so much, and I'll see you next time. Bye-bye.